Now let's take up dynamic transformation of 24 squares. The first task is to create as many rectangles as possible. So let's have a look at it. What we have here is a 24 squares. Okay. So one unit, 24 squares are there. If you count it, there will be 24 of them. As you can see over here, we have 24. Now we have to make rectangle out of it. So we almost have a rectangle. If I do this, we have a rectangle. This is one possibility. So we have one. So basically this has to be 12 and this will be 2. The first possibility that we have it on the screen is possibility 1. We have 2 cross 12. Possibility 1, by the way. Possibility 2, I can keep it as 1 cross 24. I won't be able to do it over here, but you can imagine if I stack them in this manner, I'll be able to get 1 cross 24 as well. Then possibility 3. Let's look at the possibility 3. What else can we do? So let's try arranging them in 3 rows. Let's see if it's possible. I think it is. So 1, 2, 3, 4, 5, 6, 7, 8. 8 3s are 24. Yes, perfect. So 3 cross 8. Another possibility. Let's see if we can put it across as 4 rows. This too is possible. So 1, 2, 3, 4, 5, 6. 6 and 4, 24. Perfect. So this is also possible. 4 into 6. And after that, next possibility is 5. That won't be practical because 24, if I try doing 24, you can see you're short of 1. Because 24 is 1 less than 25 and 25 can make 5 by 5 rectangle. So these are all the possibilities. Actually, should have taken screenshot, but I have an alternative. Let me take up that. So this is my alternative. Sorry. Yeah, this is my alternative. So we have one possibility. Next one is 2 rows and 12 columns. Next one is 3 rows and 8 columns. Next is 4 and 6. 6 4 is 24. And that's it. Everything else is rearrangement of these possibilities. Okay, guys. So there's one certain point. There's a certain point that you already have studied. Can you look at this set of numbers? 1, then we have 2, then we have 3, 4, 6, 8, 12, and 24. What can you conclude from all of these numbers? What do you see from all of these numbers? What is the underlying principle of the values that we are looking at? All these are factors, is it not? Factors of what? Of 24. That is, all these numbers can divide 24. Can you see that? And so we don't have values that are 5 into something or say 10 into something giving us 24. It is not possible. So here we are looking at possibilities, such possibilities. So integer numbers that can divide 24 with a remainder 0. So always remember, whenever you get any structure to be arranged, basically we are looking at the possibility of the number getting divided by a particular set of value, and if you take those values, you'll end up with that particular rectangle or a square. If you arrange them in that manner, you'll end up with that situation. Okay, which is the greatest perimeter? The greatest has to be which has the largest exposure, so that is 1 cross 24. So this will be it. So here at the bottom we have 24 length, at the top we have 24, and on the side we have 1 and 1. So 24 is 48, 1 and 1 is 50. So I think the greatest would be will be 50 units of perimeter. Which rectangle has the least? One which encloses the most. That's the conclusion that we came to, right? So let's take a look at that. Which is that? This structure. So this has 6 plus 4 plus 6 plus 4. So basically 6 plus 4 is 20, 10 plus 10 is 20. So here is 20. Least will be 20 units of perimeter. And so what can you conclude from all of this? From all of this activity, what can you conclude? So we got to see that we are able to play around with the same bunch of squares. So the area is what? Area remains the same while the perimeter can change. So that is your conclusion. For a fixed area, the perimeter is not fixed. Shape of a figure can be changed while its area stays the same, which in turn changes the perimeter. Right? The structure can be anything. To be honest, these are not the only possibilities. There are many possibilities. Even this is a new structure. This is also 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 a new structure. This looks like I think it looks like some game. If I make these two things as I, right? That's a possibility. Okay. Anyways, the point is, for a fixed area, the perimeter can vary. So this particular simple conclusion has a lot of consequence in the future. There's a lot of application we can apply to different dimensions. You might not understand the word dimension now, but some point of time, if you hear the word dimension, it's related to this. Okay, guys. So yeah, it's a very commonsensical thing, right? Very interactive, very commonsensical thing. But all these small things only add up to complicated concept. Complicated concepts are not complicated, provided you understand the basics. Okay, yeah, you can pause and have a look.